All right, I want to welcome everybody to our talk about Spring Data REST, where we get to demonstrate how data meets hypermedia. And we actually have 3 people talking at this presentation. What I wanted to launch it off with was, first of all, does anybody remember this? Okay, a few people back here. The best game ever invented, and and to me, I thought about as I've, the past year I've worked on Spring Data REST, the discovery of it, hypermedia brought this back to me because I felt like you only need a few tools to actually accomplish anything, like learning some directions. You enter the dungeon and you've only seen one room of this adventure, and you can go north, south, east, and west, and you can pick up a sword and you can attack the troll. And from there on, you have to figure it out on your own based on what you can see. So the results can be amazing. I played this game for hours, and now you can actually get it for free if you want it to download and play again. So, but not on the Wi-Fi, or Peter's going to come and get you. So I looked around for an example, and I remember playing this level, and I enjoyed the part about enter gate, attack gate, and this was neat because back in the early 90s, it was like, how the heck did they write this code that could parse this stuff? Attack gate was sword. And if you go and start digging into hypermedia instead of hard coding URIs, you find that curl can sort of do the same thing. There's other REST tools out there, but I find myself all the time jumping to the terminal and doing curl. That's an implicit get command, or you can do posts, puts, and patches. And we're going to get into that in a little more detail. But we're going to unfold and discover what the heck is all this stuff that I'm getting, and why is it good for me. And with that, I want to introduce Ollie here as our Spring Data Master.
We weren't discussing that slide before. That happens if you let other people prepare your slides, right? Yeah. Has anyone attended my talk yesterday? Okay, so we can skip this. So I'm pretty much here to just set the foundation for all of you to understand what the Spring Data REST project actually is, and outline a few design constraints or design decisions that we made with the project that really affect how it's actually working, and also affect how you actually work with it. We had some interesting discussion yesterday evening about, okay, how do you actually structure your domain model, and how do you expose those REST resources that front your domain model. And it turns out that there's the interesting bits are in the details here, and how you have dependencies between classes and whatnot. So Spring Data REST started as we realized, okay, we have this repository programming model in Spring Data. And what a repository, I mean, that's actually one-to-one from the Eric Evans domain-driven design book. What it actually is, or simulates, is a collection of entities, right? And so with the repositories, you get access to, like, let's say, all of your customers. Each customer is one by one, and you can have predefined filters, which is what the query methods effectively are, right? So you find all customers by their last name and whatnot. And that kind of nicely translates into the way people used to build REST web services manually. I mean, Ruby on Rails started it just having like /customers/customers1, right, for the customers and individual customers. So we thought, okay, if we take the repository and apply some predefined rules or design decisions to that, can we actually generify the creation of these REST resources for you, so that you don't have to repeat yourself over and over again, creating a controller with get, put, post, delete, and just writing the very same boilerplate code over and over again. So that's effectively what Spring Data REST is in a nutshell. It's supported by, I think, JPA, Gemfire, Neo4j, MongoDB. There are other stores supported already. It's just that we, for those 4 stores, we have an very intense integration test suite so that we test it works. But I've heard even the community projects work on top of it. So as long as we have a repository API, and there's a bit of details in the meta model that we build up, like the persistent metadata for these stores, then it should work with Spring Data REST. Coming back to Greg's example, and Greg and Roy are going to unveil this in much more detail. The things I'd like to outline here, and this is a very, very important one in terms of the design of Spring Data REST, is if you look at that, this is not a structure or something that we actually made up or invented. What you see here is a HAL representation. So we are actually building, or had made some design decisions to actually build the representations and the way Spring Data REST works on top of internet standards. So we're using HAL as the default media type, and I think we have an example for that in a second. So HAL is the media type that we use by default. You can switch to a custom one as well. There is a thing called ALPS I go through in a second for API documentation or discoverability of the API. And we use things like the URI templates and like the profile link relation. So what's the important point here? The important point is that if you build a client for a service, for a Spring Data REST build service, you're not building a client for a Spring Data REST build web service. But you build a client that is able to actually work with these standards, so it's compliant to these standards and can interact with those, right? So coming back to this here, the general structure here is HAL, right? So if your client understands HAL, it will understand how it will be able to find links in that JSON document, effectively. That's what HAL defines. But then it sees we have a galleries link, we have an items link, and we have a profile link. And without any further knowledge, the client can hardly make any sense of that kind of stuff, right? So the second thing which I had in the list right now was the profile relationship. There's actually a standard that defines that a link named profile points to some other resource that documents the service in some degree. So if your client understands the profile relationship, it can now see, okay, there's this profile thing going on. I follow that link, and whatever I find there is the documentation. Right? In this case, you can guess that from the URI. It's an ALPS document that will effectively describe what galleries means and what items means. Yeah? And the first and final bit of the piece is that we use not only URIs, as you can see over there, but URI templates that advocate the presence or the ability to hand in a page, a size, a sort, some projection into that resource to customize the outcome. Right? And that's all advertised, and clients can leverage that kind of knowledge. To come back to HAL, it's a media type. It's not really standardized yet. But there's two flavors of it, HAL JSON and HAL XML. The stuff you've just seen, of course, is the JSON one. And the important bit actually is that, I mean, why do we choose HAL in the first place? It's a very simple media type. It doesn't try to cover too much. It basically defines this is how links look, what links look like. And there's an _ embedded property that allows you to pull in previews of like linked to documents. Right. So that's been an important feature that we needed, and that's why we built on top of that. What can you actually do with that kind of knowledge? With the knowledge of how links are actually structured and what you can do with those. There's a thing called HAL browser. That's the UI, you find that library that you can actually, it's a JavaScript application that you can actually bundle with your service and point it to your REST web service, and it will build you a generic UI that actually understands the links. No, it doesn't really understand the links, but it finds the links in your representation and provides you with some UI to actually browse the API and poke at it, right? So that's effectively it. Okay, the final bit, and then I hand it over to Greg again. There is a standard evolving these days. It's called ALPS, Application Level Profile Semantics, and where is it? Spring. Let me go.
It's running.
Which one?
You can go to this tab, or
to this one.
Yeah, go to this tab and you can curl it.
It was curl. What was it? HTTP.
You can just do localhost 8080.
oh gosh, this way. American keyboard, that's kind of weird. Not for you guys, but yeah, we saw that resource here. You see that there's this profile link. I follow that one. Go to Alps, and what I get here is I get this is an Alps document effectively with two descriptors saying one is named orders, one is named customers. So if I want to find out about what customers actually means and what I can do with it in the in the original document, I follow that link because there's this match on customers, right? So I just follow the link there and go with customers, and then I get a document that has quite a few information in it. The first thing we get is a description of the representation. So there's a descriptor called customer representation, and it has a gender field. That it's an actual field is expressed by the type semantic here. And you see that because it's an enum in the domain model, you actually get the values printed out here. So these are the two that you can use. And more importantly, you actually get there's the customer's name again, right? So when you find a descriptor that is of a non-semantic type, there's other types like safe and idempotent and non-idempotent. Unsafe, I think, is the word that Alps uses. That pretty much indicates when you find a link called customers, you can follow that link with the GET request, because that's the only HTTP method that is safe. And it will return you a customer representation, which is effectively what we find up here. And that's how you actually find out what kind of properties you get back. There's more to it in here with like advanced topics of Spring Data REST, like the excerpt projections and whatnot. But you also get indications that you can do unsafe requests, which means post requests, or idempotent requests to update or delete the customer in that description, right? So a client can effectively go ahead and, like, from the very service, discover the semantics of that service and act accordingly then. Okay, so the whole point I wanted to make is that you're not really building a service against Spring Data REST, right? The URI structures that we define or something, but you use these HTTP or internet standards and hypermedia to a large extent to actually interact with the service and discover it effectively. And now it's up to Greg to actually show you that as an example.
Just a quick intro. My name's Greg Turnquist. My primary job is I work on Spring Data REST, but I contribute to lots of other Spring projects. And sometimes when I run into people at conferences, the thing they remember me from is the hundreds and hundreds and hundreds of commits to the Getting Started guides that I work on. But what it's time to do is we've sort of given you an intro to what is hypermedia and what does Spring Data REST based on, but now let's head towards a live visual demo. And I want to explain what we're going to demo. We have, on the left-hand side, we have a front end. We actually have 3 front ends that we're going to demonstrate. I have a classic web browser app that we'll view from this laptop. The second thing is a mobilized version of the web page that I built with jQuery Mobile that I'll use my iPhone with. And then when Roy gets up on stage, he's going to demonstrate a native Android client that are all talking to the same back-end RESTful service served up by Spring Data REST. And so the technologies involved here is we have a little bit of Spring Mobile plugged in so that it actually toggles between which web page it's serving up based on the user agent settings, and we've started in a little bit of Cujo.js for doing REST calls and also using When.js. And so if you want to find out more about Cujo, yes, the guy in the back corner, Brian Cavalier, about that. And then Roy's material, he's going to go into more about Spring Android. The server-side components are Spring Data REST, which is basically a collection of Spring MVC stuff from the Spring framework. It also plugs in Spring Helios and some other customizations. And then on the back end, we're going to be talking through a Spring Data JPA. So we're persist it to a relational database. And in this case, for the demo, we're using a H2 in-memory version of that. And so what is this app? And I got the inspiration when I saw the movie, the Interns, with the two old guys that go to Google on an internship to try to get in. And the one guy has this brainstorm idea about taking pictures with his iPhone and uploading them to social media and talking about his $1 million idea. And one of the other Google hacks is saying, well, actually, it's a $1 billion idea because that's what Instagram is exactly. So I came up with Springogram. So let me go fire that up. We can get a little visual look at it, and then go look at what's behind it. So what did we have to code and not code on our behalf? Okay, let's get it up. So now you can see let me zoom it here a little bit, my very unresponsive web page. I am not an HTML guru. I've been learning JavaScript in the past year. So when I showed this to some of my more talented people, they said, whoa, from the 90s, HTML tables and all this stuff. But what we have here are basically two pieces of data. Here we have, the first thing is of course, a cat found in the interwebs. And this cat happens to be associated with the collection of cats. But down here we have another cat, a caterpillar, which I got from Ken Cousins' blog post when he was demonstrating how to fetch cats from images.google, and a cat showed up in one of his live presentations. So we have this, and basically I can come in here and let me pick the collection of trucks, let me put this into that. Now I've linked it together. Not really that fancy, but it was a nice little demo of how to link stuff. And let me grab another image here that I can go and upload to the site. Let me pick it, let me upload it, scroll it down. Here's my new image. When I got my nice new monitor, and it's like, so is this worth $1 billion for an acquisition? Well, I don't know about that, but. So what is behind all of this? Well, what Ollie was doing there was pinging another demo app. Let me zoom that a little bigger. Again, you got a sneak peek at that. This is like if you go to the root of the document, this is what Spring Data REST is serving up, and it's showing you that you can go into either items, which are basically where I have all the pictures uploaded, and galleries, which is sort of a collection of containers. So the idea is I could have two pictures in one gallery, another picture in another, or the item could be in no gallery at all. Let me now, I'm going to do this and get ready. That was a whole bunch of stuff that flew by, and we're not in the matrix, but instead that is actually an encoded image that's stored. And I'm going to point out that this is not the way to actually upload images. This is what you do for a quick demo. The images get converted into base64 encoded data on the client. We put a prefix to make it into a data URL and put it in the JSON stuff that gets pushed up to the server. That actually adds about 25% of overhead to an image file, and databases crumble at that stuff, which I discovered when I deployed this onto Pivotal Web Services and started tweeting links at the conference to some of my demo images. And it was too much for the app. A proper solution is to upload the picture, move it into an actual file. But it's just for good demo stuff. But let's go take a look at the code that's behind this and find out how simple this is. I'm going to put this in, where's it, presentation mode. Okay, so I called it an item because this is a JPA entity class. We have an ID. I basically gave it a name. The image is stored in a plain old string, and this was basically the trick that I pulled to build a demo without having to go through multi-part uploads. So don't necessarily do that correctly, but I put a JPA-atlob annotation on it so that it would force it to store it as a varchar of any size, instead of, I think by default it was limiting me to 255 characters, which is kind of hard to fit a 3 megabyte image into. And then it has a relationship, a one-to-many relationship between, a gallery can hold one or more pictures, the way I defined it here. And I'll come back and point out what HTML URL is in a little bit, but the rest of it's basically getters and setters. The other entity class that we have here is basically the gallery class. It also has an ID, it's got an attribute called a description, and it has its list of items, which is its one-to-many relationship. And in classical relational database stuff, the foreign key is actually held in the other entity to point back to this guy, and that's what map by is there to signal. When you're building a Spring Data app, then the corresponding thing is you need to define a repository. So here's my repository. I have, in this case, I extended paging and sorting repository, and it points out that this repository is based on the item object. Now, paging and sorting repository is what gave us several extra, let me see here. You notice these extra query parameters like page, size, sort. I can go in and actually declare I want to look up page 2 with a size of 3 items. If I want to trim down exactly what queries that I want it to run on the back end and trim down how much data it's going to send me over the pipe. So instead of sending me everything and trimming it at the client, I can reduce my bandwidth consumption by using the paging and sorting repository. That actually interface is in Spring Data Commons, which means this code right here has no direct tie to JPA. It would work on MongoDB or whatever is currently working. Now, what I wanted on the web page was I wanted to be able to say, well, find me every picture that is not linked to a gallery. And in this case, I just write the query. At first, I thought I had to write a null check, but I found out that Spring Data by itself and its query finder methods has incredible support. So you can say is null, is not null. And if you went to Ollie's talk, you would have seen a lot more examples of that. And if you can go visit the documentation to learn about how to write finders. Let's go look at the corresponding gallery repository and find out it's even shorter. That's the kind of code I like. The code that has no code, it has no bugs. Now I'm going to show one other handy feature that we added to Spring Data REST. And it's a feature called projections. And when actually Ollie implemented this feature, and the minute I heard about it, I was like, that's exactly what I need, because when I would experiment with curl, I would get a 3 megabyte file converted into base 64. It looks like the matrix if you're trimming through it. And I said, I need a way to pull down all the URIs for the images without the image data. And that is what a projection can serve. Let me try to show you what I'm talking about. If I go to items 1, because let's assume I queried items, and I saw that huge thing, I scrolled back and found that the name of the cat was items was number 1. If I fetch that, I get all this stuff. It's kind of unwieldy to work with. I can see there it's cat.jpg, and I have this huge encoded data. Down at the bottom, and it comes with another link called HTML URL, and that actually is the way to take me to, instead of this record, give me a web page to view it, as well as the how links at the bottom. You notice it says it has a projection. Well, if I do projection, which you'll notice has the same name as this projection, what it's going to do is, instead of fetching me an item, it's going to take item but run it through this essentially as a filter and say only the getters that you serve up here is what's actually going to be served up over the wire. And you notice that I've left out get image. All it has is the name and the HTML URL. So if I do that, then I get a trimmed down record that I can go and interrogate and say, okay, what do I want to do with this? Do I want to do a put or a patch to it? Do I want to alter it? Or do I want to turn around and go back and fetch it in a multi-threaded context? Yeah. So, yeah. So here, I've given it an interface name, but we have an @projection annotation, and I think that the projection annotation in Spring Data REST. Or I don't know if that was is that in Spring Data REST, the @projection annotation. So this is like the name that I would use on the from the REST client is no images, and the types that it can apply to are right now the item.class. I'm not sure. I couldn't hear that. Just a moment. We're going to now keep the questions coming because we'd like to answer. What's.
So the question was with JPA you use or have relationships to other entities. Can you manage those or the inclusion or non-inclusion into the representation using these projections? That's exactly what they were meant for, because if you have like two repositories managing entities and they are related to each other, you would by default see a link, right? Because repository indicates this is an aggregate root, and you actually have to manage the life cycle of these two individually by creating the objects and whatnot. But if you want to create a representation where one is embedded inside the other, just for like a use case, I think I brought up yesterday in the call, where you have like a master detail view or something, and you don't want to like follow link relations all the time, you can create a projection that actually shapes up the representation just as you want it by just having the inclusions in there. You can even use the add value annotation and a spell expression to pull in data from some other place, or so enrich that thing or hide away things just as Greg did, and then provide that to your clients using the no images name in this case, so that the clients can actually access that particular representation of the object. You can also use like Jackson annotations on that thing, so we effectively build a proxy object for that and hand that to Jackson, and it will consider all the customizations that you have in there, custom serializers, whatnot. So that's pretty much it.
The question is, can you discover the projections at runtime? And right now, I'm not familiar with that that's possible yet, but it's
yes, you can. Of course, you can. Can you fire up the console real quick?
Yeah.
You see that projection. Like when a projection is available for a resource, we indicate that in the first place by enriching the URI to that resource with that template variable. And if you follow the ALPS stuff that I showed you before, the ALPS documents, the metadata documents, they actually contain the values that are valid for that projection. So you find, you find the same. You have a descriptor called projection, which maps to the request parameter. So you find out, okay, this is the value that I can pipe certain names into it, and you see the no images value there. This is effectively the value that you can use, and the even more nested descriptor there defines which values you get returned if you pipe no images into the projection variable. So it's pretty much covered full stack there.
I did not know that. That is great. I want to explain I want to quickly point out what this HTML URL thing is, and I figured let me throw up the mobile interface and we can keep taking some questions from that point. Let me go back to item. The other thing I ran into is I wanted to make it tweetable, so I wanted a one-page view of a given image, and I would call it, instead of a Helios-based URL, let me get an HTML-based one. And so I have a manually written Spring MVC controller to serve up a different template. And in this case, I use the Spring Helios project's ability to give me a link to the method on application controller.image. So go to the application controller class, find method named image, feed it the ID that I happen to have related to this record, and when you render the link, here's the name to give it, HTML URL, which is what shows up in the hypermedia. And what this does is it basically gives me, it's a way to quickly create a link to this, and it's going to go look up what the Spring MVC route is. So if I go in here and alter the @request mapping and change it to something totally different /foobar, the links will automatically update the next time you run it. And the thing is if you're navigating by fetching, saying, give me relationship HTML URL, and you're not hard coding the URIs, then it doesn't matter. It's not going to affect the client because they're navigating by the hypermedia name, not the URI. In this case, see, the idea here is you have a name of a link, or called, well, this is a manual attribute called HTML URL, and in this case, it's a Spring Helios link, so it has an href, and in this case, it's /image/1. So that's an alternative record to fetch that is not a HAL document, but instead actually renders a Spring MVC template. You know, and it's the image up above, and it says, hey, tweet me. Let me pull up the mobile interface like I just promised. All right, come on, AirPlay. Let's see if I'm on the right network. Yeah, it put me back on Spring 1. Let me go to my local setup. This is the biggest thing I wanted to do for this demo, was to be able to put up a mobile app. And this is the proof that it's a live demo. Okay. Connected, come on. There we go. All right. All right. So this is a fun app I found out there called Reflector, so I could stream my iPhone to my laptop for presentation. So now we're, this is basically, I'm visiting the same app, except it serves me a different set of time leaf templates. And you know, we can see the picture that I just uploaded. I can tap on it. It pops up a little thumbnail picture. I've got a share button. If I go back to the home page here, I can look at the list of galleries. I can see, let's see, there's the cat. There's the other cat. And then the big show off is here. If you hit this, let me take a picture. All right, let's do that. Oh, uploading image. When you upload a 3 megabyte image, it takes a few seconds, and it takes a few minutes if you're pushing it remotely in this format. So let's see if it's still... maybe still fetching it. Part of the reason I wanted the no image projection is because I was using RestJS to go fetch every image. And there's our picture posted up there that I just took. If you go and try to fetch, imagine there were 10 pictures up there. A standard call that would say, give me all pictures that are not associated with the gallery. It's going to download 10 times 3 megabytes or 30 megabytes all in one swoop. And that's before it renders anything. So this is when I discovered When.js from the Cujo guys, where I could say, let me fetch all 10 without the image, and then for each individual URI, let me go back, queue up a request to fetch each of them one by one with their images, and when they all come down, turn off the spinner. The question is in the context of projections, can you use them to alter the data? And my understanding is essentially it's basically you're inserting an alternate set of getters and setters. In this case, I'm using them as pass-throughs, but I guess if you want to put business logic into it, you can manipulate it.
I'd be interested to hear what you mean by alter the data. Right. Right. To repeat the question for everyone, so the use case is, okay, I might want to expose the image still, but I want to have it in a different resolution or something. So pretty much enrich the representation with something related to what's originally there. That works. Do you have the slide handy with just the bit of code that the IntelliJ is fine, I think.
Oh yeah.
With the projection. With the projection type. So what you can do is that... Sorry. No worries. What you can do is that you can have arbitrary methods in the representation. They need to follow the bean accessor semantics to derive a name from it. But what you could go ahead and say have public and still have byte array condensed image or something, and then have an add value annotation on it that takes a spell expression that effectively triggers some Spring Bean that like looks up the pre-rendered tiny image or renders it on the fly, right? There's the spell expression gets the target object, so the actual, what is it? The item is available via a reference like target, so that you can call other methods on the target. Like yesterday in the example I had target.firstname plus space plus target get last name, so to combine the names. But you pretty much get the full power of spell and accessibility of all the Spring Beans and whatnot, so you can just build whatever you like there. The only limitation here is that it's a read-only concept, so the post requests and put requests to the resource still have to like be compatible with the non-projected type, right? So that's the only downside here. But beyond that,
okay. I think we did it.
So the question is there a way for the client to define which properties it wants to get back? The answer is no currently. The reason being that we thought, okay, that puts a lot of emphasis on the client deciding what it needs, which might be handy, but also creates like a lot of options and tons of options that we might have to support. So we rather went with like predefined sets of data so that the server is in control and in charge of what it delivers. I think there's an open ticket for that, but yeah, we're not decided on it whether we want to go down that route. We pretty much thought this would be a cool approach in the first place, and see how far people can get with that. The primary reason is that this stuff is easier to document and expose, right? We know there's no images thing, and we can pretty much tell the client what it gets. If you have to communicate the option or non-option of including fields or non-fields, then it gets more tricky in this case. Right?
You know, and another debatable point on that is at what point have you departed the paradigm of REST and serving up and discovering what the server offers versus you're now writing a query language that's just over the web. So, you know, with this relatively lightweight approach, if your customer comes to you and says, well, I'd really like this alternative view, it's minimal effort for you to go add one more interface projection to and roll it out potentially. So, but you know, it's up for debate. Any question?
So this way we can view what we show. Is there a way to exclude from these? So let's say from item class, I don't want to show.
This is essentially what this is, because I had actually run into a bug that I didn't realize at first, which is at first I had the name and the image, which was the name is cat.jpg and the image is the raw data. Later on, to render the single page view of it with the time leaf template, I added HTML URL and had it use Spring Helios to fetch the link. I forgot to add get HTML URL to this projection, so I kept wondering why my client was breaking, because it was excluded by not being there. And so it's filtered out by whatever's not there is not getting passed on through, and that's from the server side. So it's not filtered on the client side, it's filtered before it goes over the wire.
Basically, you're asking that I want to show everything from item class, but PHP URL. So it's like the video is adding everything in here. So is there a way to just say?
So I guess the question is there a way to invert this interface so that I can whitelist precisely what I don't want to send back? And right now we don't have that's not supported right now. And I'm not quite sure how, because we're sort of leveraging the existing Java language to do that. But yeah, was there another question or so? I didn't see. What I want to do at this point is, I was going to turn it over to Roy to give him a chance here, and we need to switch laptops to. Let me take it out of presentation mode here. Was. Oh, the question is, well, what about custom queries? I'm going to turn off Reflector here and go over to the repository interface. Sort of a more backfill on what does Spring Data have is if you maybe I should go back in presentation mode. Oh, that's not what I wanted. Okay, if you look into what these interfaces are that come in, basically paging and sorting adds the extra paging and sorting stuff I mentioned earlier, but it's just a sub interface of CRUD repository, which comes with pre-built operations like save, find one, delete, and Spring Data REST automatically maps those onto get, put, post, patch. But in this sense, what I had in the item repository was I wrote one custom finder, find by gallery is null. And this is where we're using the familiar Spring Data concept. And to get a more in-depth thing, I recommend you go out and buy even though it's 2 or 3 years old, the Spring Data book that Ollie and Michael Hunger and John Brisbane and Mark Pollack worked on, and some other people, because they go into a lot more detail about these finder methods, and essentially Spring Data REST supports them as well. If you go into items, they'll have the search. Yeah, it's in. When you go down, that link would have been up there, but it's kind of clouded by all the data that I have in the thing. You find out every finder method you've written will be actually registered underneath the search, and so you can find the name, and it'll give you the actual path to it. And in that sense, I can find my finders this way. If I can. Now if I do that, it's going to give me the nulls, and I can apply the same projection. And so in this, so I found in this case the only unlinked item was that other image that I had uploaded. I think I already assigned the picture that I snapped and added that to another collection. So I don't know if that exactly answers your question or not. I believe the sorting is built in because we're extending paging and sorting repository. Well, what about customizing the query from here on, like sorting, or if you want to go and actually restrict based on, well, I'm actually looking for anything that like where name is 4 star, that's not built in. You need to go back to the server side and write a finder method based on that. If you go write find by name and then name, it then will become an available search on here, but you can't automatically start searching on every field that's available through the RESTful interface unless you write it in the back end. Yeah, or was it ampersand? Oh. 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 So. Okay, let me get this almost back up. I don't see it. Maybe I don't know if it's the projection. Okay. I don't know. We may have to revisit this subject. I guess the point I'm trying to get to is like sorting's built in, and I actually didn't test any of the sorting stuff, so that's why I'm slightly off script. But if you want to write a specific finder based on a particular attribute, you can go back and define it using conventional Spring data operations, and we'll show up here just like I wrote this one that has no parameters. But let's go ahead and get Roy hooked up. Let me move this out of here, Roy.
Thanks, Greg. These guys aren't running away. We'll have them back up here so we can answer more questions. So let's see. I think we look good. Okay, my name is Roy Clarkson, and here's sort of my biography in form of image thumbnails. I'm the lead on the Spring 4 Android project, and also the Spring Mobile. And Greg and Ali and I talked a few weeks ago, earlier this summer, about putting together a Android client that could consume a Spring Helios and HAL-based REST service built on Spring Data REST. So that's what I'm here today to show you guys. I'm just going to jump right in. And this is Android Studio, in case you guys aren't familiar with it. It's based on IntelliJ. It's a free download from Google. Uh-huh. So did you catch that? All right, well, what happened? Okay, so my service isn't running yet, and I'm just throwing the exception message up on the screen. So let's come over and start the service. So this is the same exact code that Greg was running, but I'm running it locally on my machine. He was running it locally on his. We decided not to risk the Wi-Fi, as he mentioned earlier. Otherwise, his images would show up in here. OK, so home screen. And we've got basically the same functionality that we had on the web view. We've got photos, assuming it's working. Oh. Let's try again. OK. There we go. So we got the same photos, cat and another cat, as Greg called it. And we've got galleries, the cats and the trucks. And the cat's already assigned to the gallery. And we can go back to photos, come over here, we can add a new photo, sideways. So there we go. We're doing the same thing that Greg was doing on the web view as well. We're encoding these images and pushing it up, all the same endpoints. And if I can go over to a gallery, I can add a new gallery in here. So starting a new meme or something. So now we can go back into photos. There wasn't anything in that gallery yet. And now we can add it to the gallery. OK, so there we go. And so let's go back to the slides. That's pretty much the bulk of the functionality there. And let's take a step back. And those of you not familiar with the Spring for Android project, wanted to just talk about a few things related to that project. And in case you couldn't guess, that demo was built with Spring for Android and Spring Helios. And I'll get to the code later, but just wanted to give you fair warning that was built with those two projects. So what problem are we trying to solve with Spring for Android? Why are we doing this project? And hopefully you can get some of the answer just by seeing that demo. We've got a really nice REST client built into Spring Framework. It's called RestTemplate. And we decided it'd be really nice to try and port that over to Android. So we've got a common, if you will, consistent programming model. And that's essentially at the heart of what the Spring for Android project provides, is a consistent programming model with Spring Framework. It offers REST template class. It's powerful, it's extensible. But more than that, what we realize is we have all these amazing services on the server built on things like Spring MVC. Spring Data REST is an extension of Spring MVC. So we have all these things on the server side, and we wanted to be able to provide a nice way to consume those on the client side. And so it just made a lot of sense to go with this project and move forward with that. So a little more details about Spring for Android. What we did was we looked at Spring Framework and tried to figure out what we needed from Spring Framework on an Android client. So we tried to minimize the amount of code, because if you guys have looked at Spring Framework, it's pretty large set of libraries, lots of code. If you can imagine on a client like Android, you don't really want to have all that. It would be a huge dependency. On top of that, Spring Framework doesn't have Android in mind. at all. So they're focused on the future, Java 8, moving forward with things like lambdas. These things are not available on Android whatsoever. So with the exception, somebody brought up earlier that now we have a Groovy implementation on Android, which is totally out of scope for this, but very exciting to see the Groovy team working on that. So what I did is I went in and analyzed the Spring Core and the Spring Web libraries, and then pulled out all of the things that would be applicable to get RestTemplate working on Android. And then had to go through and port and rework some of the tests to get them all to run on all the versions of Android. Because when you talk about running on Android, you're not just talking about running on Java 6 or Java 7. You're talking about running on Android 2.1, 2.2, all the various versions all the way up. And the core libraries in Android change from each of those versions, sometimes subtly, sometimes there's bugs in older ones. So we try to really protect you from all of those details and all of those underlying issues that you might have running an app on Android. And so here's the project page and the GitHub page as well. So just to review a little bit about RestTemplate, it's been around a while, but it supports all of the major HTTP methods. And as you see here, delete, get, head, options, etc. There's a number of methods for each of these, and that's what the little ellipse is for. There's a number of overloaded methods for all of those: delete, get for object, head for headers. All of those eventually drill down to an exchange and execute. So if you want to just go straight to the source, you can use an exchange or execute method. And here's an extremely simple example. And really, this isn't that exciting because we're just getting a string back. But basically, you can pass in a URL template, and some values, the 42 and 21, would get mapped over to the hotel and the booking parameters in that URL. And this get for object method is going to return a string. It's going to, what we call message conversion, and I'm going to get to that a little later, but it's using string HTTP message converter to convert the response coming back from the server, in this case, and put that into a string result. So here's some other examples of HTTP message converters, and we've had support for Jackson forever in Spring Framework, and now, of course, we've got Jackson 2. But more recently, and this didn't make it onto Jürgen's slide, but I'm pretty proud of it. I actually contributed the JSON HTTP message converter, and we've had it in Spring for Android for a while, but now it's actually available in Spring Framework 4.1 as well. So you have a choice between using Jackson 2 or JSON. And then on Spring Framework, this is just an example of something that's different. We don't have support for things like Spring Oxum just because the underlying Android library doesn't support it. So there's another third-party library called Simple XML. And so we've got a message converter for that. And it allows you to do marshalling with XML just like you would with some of the complementary message converters on Spring Framework itself. The challenge with using different message converters for XML is that if you annotate something on the server, you can't necessarily just copy that POJO or object over to your client like you would be able to if you were using Jackson or JSON. So things that are annotated the same for Jackson, you could actually duplicate those objects. You could produce it on the server and consume it, the exact same object on the client. OK, so I'm actually here to announce today that Spring for Android 2.0 M1 has been released. I pushed the release out earlier this week. I actually haven't published a release announcement yet because we've all been very busy with the conference this week. But it's actually now available. And look for the release announcement within the next day or so as I get back and have some free time to work on that. So some of the highlights of it are we've added generic support. And this was going to happen at some point anyway, but this really was driven out of talking with Ollie and Greg about trying to support Spring Helios on an Android environment. So it was critical that we included generic support. And we also added a new HTTP client support based on OK-HTTP. And I'll get to some details about that in a following slide. Because Spring for Android's a fork of Spring Framework, the REST templates was a fork. It had started to diverge a little bit, which is just natural for a fork. And it's also the challenge of maintaining a fork. So one of the things that I tried to do in this 2.0 release is bring back some API parity. There had been some real challenges around supporting slightly different versions of REST template. And so now this 2.0 version, the API is consistent with the API in REST template and Spring Framework. And that's really critically important. So people, when they have questions about one, it's applicable to the other. So very happy to actually reintroduce that parity. And that's always going to be a goal going forward with the project. It's just that, obviously we've got different audiences, and sometimes you need to support things on Android that aren't necessarily relevant for Spring Framework. Updated all the dependencies, a number of bug fixes. And because essentially the REST template in Spring for Android is sort of following along Spring Framework, it's never going to be exactly current. And because we got to do a lot of testing on Android, it's a significant testing effort to make sure everything works correctly. So right now, the 2.0, when it goes GA this fall, is going to be based on the latest 3.2x release. So in terms of supported Android versions, this graphic's from the actual Android developer's website. So the Google Play app now is supported. The minimum version is down to Android 2.2. And when we first released Spring for Android, we were supporting 2.1 and newer. And since 2.1 has been dropped, and it's also not even showing up on the pie charts anymore for Android, we're actually going to be raising our minimum version to Android 2.2 as well. So, and anybody who's done any Android development is probably agreeing with me. They're very thankful that Froyo and Eclair have sort of fallen off the face of the earth. Gingerbread is such a significant improvement over those two code bases. And additionally, the Jelly Bean is now over 50%. I'm very excited about that. So again, moving forward, our minimum version for Spring for Android is going to be Android 2.2. Okay, and I mentioned HTTP clients a little earlier. There's two native clients that are built into Android. One is based on the standard J2SE facilities. It's a URL connection. And the other one is based on HTTP components, HTTP client 4.1. And Google published a blog post a couple years ago, maybe not that long, about their development strategies around these two native clients. And they essentially said that the HTTP client was too much trouble to maintain. So after around Android 2.2, they highly recommended, in Gingerbread and newer, which is Android 2.3, they recommended using URL connection. And Spring for Android is going to seamlessly choose which one. So it actually checks the version of Android, and if it's older than Gingerbread, it's going to use the HTTP components client. And if it's newer, then it's going to default to the URL connection. And obviously, I just said that we've moved up to Android 2.2, so that means that really only Android 2.2 is the one that's going to default to the HTTP components client, which is good. The URL connection is in a better state. Although, as time moved on, it became more clear that even in Gingerbread and some of the earlier versions of Android 4.0, URL connection had some pretty significant bugs. And the only times they were getting fixed were in newer versions of Android. So you can imagine you've got like an earlier Android 4.0 version that's got a fairly significant, basically a thread pool issue, and it doesn't get fixed. It's never going to get fixed in the version that you have. The only way it happens for somebody to get it fixed is to get a new phone. So and that's just, if you're writing an app, that's really not a good solution. In steps the developers of OK-HTTP, and this is built by some guys over at Square. And one of those guys actually used to work on the Android development team. He was one of the people that worked on the HTTP clients in Android. So it makes sense he knows what he's doing. But OK-HTTP is actually supported all the way down to Gingerbread. It does require a third-party dependency. But what it means is you can now get updates for your HTTP client, your underlying HTTP client that's used by RestTemplate, instead of just hoping everything works okay. So we have tried to work around some of the issues, but some of them are just they're just issues with the underlying HTTP client. So it's good for the Spring for Android project that we now have a third-party HTTP client that we can utilize. And then this other one is the HTTP components 4.3. Apache's done a lot of work to port the 4.3 version of their HTTP client to an Android-compatible version. And we don't have support for that yet, but that's on our roadmap to include in an upcoming release. So, and at that point, you'll have two options for two third-party clients, and hopefully offer a little bit more stability from the underlying HTTP client. Okay, so I mentioned generics, and this is why generics is important. Unfortunately, it's also ugly. So parameterized type reference was introduced in Spring Framework a little earlier, and now this is actually available in Spring for Android. But you can see this resources object that's in here. It's just nested generics. So basically, because of Java's type erasure, you have to have a way to hold on to that underlying type, and this is it's called there's a blog post about it. It's called Super Types. I recommend looking into it if you're interested. But basically, the way that we work around this in RestTemplate is through the use of this parameterized type reference. And Ollie and I have talked about this, and one of the things that we're hoping to do is, in this collaboration, is to actually make that look a lot better. So hopefully in a newer version, and I say hopefully, we are going to, in an upcoming version of Spring Helios, we're going to have a nicer object to use instead of having to put together this thing. Basically, it'll make consuming how resources much easier. So this would be how you make a how resource through RestTemplate, how you make a request for a how resource. Okay. So I mentioned some of the project roadmaps for Spring for Android. I mentioned the HTTP components. One of the next things that's really important to us is to get async RestTemplate in here. If you guys aren't using it yet and use RestTemplate, then I highly recommend it, because it's obviously an improvement over just the regular RestTemplate. We already have Spring Social integration, but we're going to work on improving that for an upcoming release. And I mentioned the support for Spring Helios. We want to have really good seamless integration. It's important that you're easily able to consume Spring Data REST services built with Spring Helios. And a little further down the road, we're really hoping to implement some WebSocket and differential sync. And reminds me about differential sync, there's going to be a really good presentation tomorrow from one of my teammates, Brian Cavalier, who's sitting in the back there. And I think it's at 10:30, is that right? Yeah. So he and Craig Walls, who's on the lead on the Spring Social team, are going to do a presentation on that. And so I recommend going to that. And we've got a number of getting started guides on Spring.io around Android, and this is just a selection of them. But if you go to the Spring.io guides, then you can find all of those. There's also a number, I didn't have the links for them, but there's a number of Spring Data related guides on there as well. Greg and Craig and I actually worked many months last year in coordination with the Spring IO website redesign to write and author all those guides. It was a lot of work, but I think we're very proud of it, and I think there's a lot of good information in there. Okay, so you listened to me talk about all the Spring for Android stuff. Now let's go over to the actual code and just look through that. Okay. So this is a demo app that we built over the last few weeks, and not not months and months worth of effort. So it does everything we needed to do. Okay, so the first thing that happens is the home fragment is loaded, this screen right here. And what's going to happen is that we do basically a phone home and download the root resource, is what I call it here. And we'll zoom in. Okay, so the question is there a single jar file? And so I can back up just 1 second. So we've added a repository for the libs milestone. And then in the actual app build.gradle, down here, here's your dependency. So we have Spring Android REST template 200M1, and then we have the Spring Helios coming in. And so that takes care of that slide that I showed you earlier, but the nice graphics on it. And then additionally, we're using the Jackson data bind in this, and as well as the JSON path library. So one of the things to really note here, and this is just an ongoing development issue between Android and Java runtime. Spring Helios has a number of dependencies, some of which are Spring core libraries, and those things just don't work on Android. So I'm not utilizing any of that functionality, but so in this case, I set it to transitive false for this Spring Helios dependency. So it's not going to pull in any of the transitive dependencies for Spring Helios. So I can leverage things in that project without having all the other cruff coming into the Android app. Does that answer your question? Yep. Okay, so coming back here, this is the initial entry point. We're doing a REST template call, and let's see. I created a little REST utils class. Essentially, this has got a static instance of a REST template, so it'll lazy load it. But instead of creating a new instance of REST template every time I need one, I just have a little utils class that does this. And the same thing for the request entity, because we're setting the media type as HAL plus JSON, application HAL plus JSON. So every single request is requesting a HAL resource. So just go ahead and set that, and then I can reuse this in every one of the requests. So coming back over here. Yep, so API resource, we can go look at that. Essentially what this does is extend resource support, and resource support is one of those classes from Spring Helios. So if you have an object and you extend resource support, and then it implements all of the HAL metadata for you. So you can see in here it's got links, iterable link. Yeah, so lots of good information here. Yeah, so one thing to note here, you can see it's in red. This is just calling out another difference between Android and Java. JAXB is not available on Android, so within the Spring Helios resource classes, they're annotated with the XML element, and Android can't find that. So Android Studio's throwing up an issue. So that's just an example of something that we need to work through in terms of the integration between the projects. It obviously works, even though it can't find it because it's inconsequential to the operation of the JSON functionality. But nevertheless, it doesn't look very clean. So we're going to want to clean that up whenever we do a release with this official integration. Then in here, so what I've done here is I've actually put a couple of constants for what the relationships are that are available from the root API. And so Greg had showed you the URLs earlier. I think, let's see. Yeah, so if we look at this, you can see there's two links here. One is items and one is galleries. So I basically, those are known. This starts sort of describing the issue with building a client based on Helios and HAL or any metadata. If you want to be able to customize and present your data correctly, then you really kind of need to know the data that you're consuming. So in this case, I know that I've got two rels from the root API. One is items and one is gallery. So I can go look for those later on when I want to load up the photos or the galleries. But what this means is that I don't have to know the URLs for those. And that's the beauty of the HAL metadata. So the only URL that I have in this entire application is down here. It's just the base URL. So after I make that initial request, everything else is just identified through those rel names, which is a really key point, because that means that the URLs, the underlying URLs could actually change, but as long as the rel names, link names stay the same, then your application's not going to break. Okay, so yeah, any questions about that? I think I covered all of the objects in there. So one of the other things to note as a side note, this async task, if you're not familiar with Android development, this is one of the conventions that they give you that allows you to make asynchronous requests that are off the main UI thread. Requests that are on the main UI thread will block, and it's really bad. In fact, in newer versions of Android, it'll throw an exception when your app tries to runtime exception. So one of the things that async REST template would actually take care of is at least I foresee, because this isn't implemented yet, is preventing, this is just boilerplate code that we would be able to encapsulate into async REST template so that you wouldn't have to use this mechanism every time. And so I'm looking forward to trying to get that all working correctly in Spring for Android. Let's see. So if we go look at the photo list fragment, these are all of these requests are going to look very similar. So here's an example of using the generics that I talked about before. We're creating a parameterized type reference based on the HAL resources object that is typed to item resource. And in this case, item resource looks suspiciously like the object that Greg had on the server, although I don't have all of the annotations for Spring Data REST. But again, just to reiterate, this just, because it's all Java, it's not dynamic, you still need to know your model objects. You still need to define those in your client so that you can consume them correctly. There's no silver bullet for that. So in this case, you can see that I've got a self and gallery. I've defined those in here so that I can go and find those later on. If I had known about the image adjusting projection on the Spring Data REST service, I probably would have changed that to return smaller images. But in this case, what I'm doing is getting the image data URI, the data URI, and then just reducing it significantly. So 75 by 75 and 400 by 400. Yeah, Greg spoke to that's not really the best way to design an image service. You definitely want to push that stuff into files and then return URLs. And you can see on the Android client, actually, if you start loading too many images, the garbage collector starts going crazy. So it's a little bit too, yeah, it's just not the right design architecture for doing a real service like that. But for this, it makes for a really good demo.
Does that mean we're not a $1 billion acquisition?
Just $1 million, or $50. So let's see. The other thing that I wanted to point out, and this is something that we're going to be getting into Spring Helios as well, because it can be leveraged by RestTemplate on from Spring Framework. This is how you need to set up your Jackson HTTP message converter. So I actually was almost prepared to send Ollie a pull request for this, but I didn't have the test ready, so it's not in there yet, and I didn't want to use a snapshot for this demo, so I just left it in here. But basically, this is going to make its way into Spring Helios, and what this means is that you can then use this resource mapping Jackson to HTTP message converter, and it's going to be configured to just make all of these HOW requests for you so that you don't have to go through this extra configuration. One of the things to point out here is this deserialization fail on unknown properties. Jackson defaults to failing on unknown properties, and because it's the nature of HAL to have unknown properties, you don't want it to fail. So you need to set that up. The Jackson 2 HAL module is actually already in Spring Helios, so I'm just pulling that in and using that, and it's a module for converting the response data coming back from Spring Data REST. And then, of course, setting up the media type as HAL plus JSON. By default, the Jackson 2 message converter is application JSON, not HAL plus JSON. So we want to add that and then register this message converter as an alternative to the Jackson one. And type constrained mapping Jackson, this is a message converter. This is actually another object class that's in Spring Helios. And it allows you to restrict it to a specific type of response. So in this case, it's restricting it to this resource, HAL resource object. So basically sets everything up for you so you don't have to worry about any of that. And like I said, that's going to eventually make its way into Spring Helios. And then you'll be able to use it from Android and Spring Framework proper. Okay, we are at, let's see, we got about 4 minutes left. So I think I'm going to invite Ollie and Greg back up to the stage, and we can just answer some questions in the few minutes that we have remaining. It is, yes.
Let me put up a final slide here.
This app, of course, the underlying Spring.
The which?
The app.
Yes, yeah, and they're both right here. So the Springogram, the service is in Greg's GitHub account, and then the Springogram Android is in mine.
I'll tweet it as soon as possible, but there's actually, they have a single GitHub entity, whatever, for Spring 1.2GX 2014, and so the idea is everyone's taken their snapshot copy of their GitHub project and put it in one place, so you could go to that one resource and find everybody's code from every presentation at this year's conference. But
Yep.
So you have to stay tuned for that.
Yeah, we're going to consolidate our slide decks and then push both of these into that consolidated repo as well.
Something else I wanted to invite people to do is, we've covered a lot of ground on here. We talked about server-side, Spring Data REST. I used a client-side. I wrote JavaScript. Suspiciously, I didn't pull up any Java REST template libraries because I wrote the front end with JavaScript. So I went and used REST.js that came with Helios support and HAL support built in, which is why I'd recommend it to other people. Roy went and discovered what it took to support HAL, et cetera, to make mods to Spring for Android to support that from a client perspective. And something we did not demonstrate is that the Spring Helios project itself has a API to navigate these links. The idea that you start at /API and you want to go follow a chain of relationships. So instead of going to some document you find on the internet that was marked up by Swagger that says, well, jump right to this hard-coded URI. Instead, I'm going to start at the root. I'm going to go to galleries 1 and its related items. Somebody had built a JavaScript library out there called Traverson, which you could say this is the order of relationships that I want to hop, as if you're hopping the web. And Ollie went and wrote a Java API that was similar to that. And if you go to the Spring Helios project, you'll find documentation for that. And in the similar convention, I wrote a JavaScript function that sort of did the same operation, because at the time I was writing this demo app, Traverson was in alpha status and couldn't handle URI templates. So it would crash when it saw an open curly brace. I was inviting, it's a sort of a cross-section of functionality where you have server-side people meeting client-side people, and there's people that are interested in JavaScript or Android. And so I was going to say, after the presentation's over, feel free to come and ask us questions, or if you want to meet over in the Coders Lounge, which is right down the hallway here, we can show you more details about what are you curious about, from a server-side or client-side perspective on this functionality. I don't know if there's any more questions.
So the question was, how is the ALPS metadata generated? I remember, I think, Roy and a lot of people at the company having like a few intense meetings about discussing what the approach to documenting or describing REST services could be, and Swagger being one option. But what we didn't like, that I think as of today, Swagger is quite popular, but it still has the problem that it effectively documents URI structures, which is what you want to avoid because you couple your client to it. And we were discussing two things actually. The one was how could we maybe build support for plain Spring MVC. But with Spring Data REST, it's actually a bit easier because we effectively know about the persistent properties. We know about the metadata of the API. And also we know about the which resources do we export? What are the URI structures are not interesting for a client because the link relations are right, and we know how we turn a customer repository in a link relation customers into a link relation customer and all this kind of thing. If you go ahead and let's say take your customer repository and pretty much hide the save method, for example, from Spring Data REST, we would realize that and effectively translate that into an ALPS information and hide the non-idempotent descriptor there, so that we indicate to the client, guy, you can't really update customers, right? It's a read-only resource. So effectively, we generate the JSON at runtime and inspect all the information and metadata and API we have available and all the knowledge we have available to it. And as you've seen, we can even find out about the projection configuration and indicate all that kind of stuff. But that only really works well because we have done some decisions in the Spring Data REST design effectively and can build on those, right? So that's effectively it. There's no real caching going on right now, but the interesting bit here is that we clearly separate the actual representation from the metadata. So the link effectively between the representation, like your customer, and the metadata is the link. So the link relations, these are the connecting bits. And the primary reason for that is there are other approaches like Siren and whatnot that pretty much enrich your actual representation with information which HTTP methods you can use on a link. But usually the metadata has a quite different life cycle, a much longer life cycle than the actual entities. And by separating these resources, you can apply different caching strategies to the metadata and the actual resources. So you can, again, leverage HTTP means to actually improve the performance of that if that really becomes an issue. But bottom line is, yes, we use all the knowledge that we have about the mappings, about the customizations, and expose them there at runtime. Oh, good question. The question was, is there a way to set a default projection? That's actually a feature of the release we shipped yesterday. We've been hesitant on doing that because if you enable, I mean, the question is, what do you want to customize? If you just generally apply a projection to everything, that's kind of, or creates the problem that you return a representation on the GET request that effectively is not compatible to what you would have to post to update the resource, because there's this this impedance, or there's a gap between the two representations. But as Hell has this notion of the underscore embedded, have you seen that? So there's a dedicated property that indicates whatever you find in here is some kind of a preview of something that is actually related. So there's a mechanism in the latest release where you can define, we call it excerpt projections. So whenever you render a preview, you can automatically get the projection applied. So for the collection resource, for example, let's say the list of all customers, we consider this not to be the list of customers in the first place, but the list of previews of customers that is pointed to. So for the collection resource, you would get this preview or this excerpt projection applied by default. I think, yeah, we run short in time yesterday, but I can, if you just come to me afterwards, I can show you that, how that actually changes the representation defaults and how you configure that. But yeah, that works.
I think we can field one more question here, and then we can break and continue off outside.
Excuse me, can you repeat that? I didn't get it from her.
Can you add other information like documentation about the attributes themselves or descriptions or whether they're required?
Right, so the question is there a way to enrich the in this case you probably mean the ALPS documentation with additional information. There's two ways to it. For the quick and dirty solution is there's an add description annotation that you can use in various places where you define effectively, can use plain text information in the code directly. So if you've seen that in the example, I think for the pagination parameters and stuff, we have some kind of default messages that we render. The other thing is that for every descriptor that we render with ALPS, there's some kind of like unique key that you can effectively, that's derived from the relation names and all that kind of stuff, which you can use to international. I mean, we're using the Spring resource bundles so that you can have a properties file with these particular like keys, and then have your textual description, this textual description in there. I'm not sure I find it right away, but do you have description on item? You can go with, yeah. You could go ahead and have. I think it's just add description, right? You can put it right there, or alternatively have an item.name, because the what is it? The relation type for a single item is item, just lowercase class name, and then dot property name, and then have a properties file. I think it's rest-messages or something. I have to look that up. But yeah, you can put in there whatever you want. I think the mechanism is even pluggable, so if you find something else to render it, but
do come find us afterwards. We need to
shut down.
the next
Okay,
speaker
running over
get
time.
ready. But
Sorry
thank you
for
guys
that.
for coming to the session.
Take care.